Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And I usually don't like doing like 8 by 8 Sudokus because it's very different dynamic, I feel. But I had to do this one because it tickled my well, I used to play piano as a kid. And I mean like most Asian American or Chinese Americans, I would say, in who grew up here. But I did enjoy playing piano. Um, I didn't like practicing so much, but so this tickled my fancy, I guess, because it definitely reminded me of my childhood. And let's get to it. It's called Etude for a Broken Piano, and it's by Michael Lefkowitz. Um, and it actually has all the piano keys here, right? So we have full octaves each in all these pianos. Um, and this was, I think, I know this was Michael Lefkowitz said that this was made for the pedaling pianist, who's a setter, who makes a lot of really cool puzzles, and obviously is a pianist, right? And it structures the keys from of an octave on each set of two rows, right? So this is C, D, E, F, G, A, B, and C. Or do, re, mi, fa, so, la, ti, and do. And then we have also the minor keys here, or the accidentals. The C sharp or D flat, D sharp, E flat, etc., etc. Anyways, let's get to the rules of this piano. We have Schrodinger Sudoku, where we need to place one or more digits from 1 through 9 in every cell so that each digit appears exactly once in every row, column, and region. The value of a cell is the sum of its digits. This is why I like stating normal Sudoku rules as fill the entire grid with the digits 1 through 9, such that each digit appears exactly once, so that there are no repeats. Well, okay, this must be exactly once, so that's slightly different. But it can be essentially similar, right? Fill the entire grid with the digits 1 through 9 such that each digit appears exactly once in every row, column, and region. 8-cell region, then, in this case. The value of a cell is the sum of its digits. Right, and you must place one or more digits from every 1 through 9. From 1 through 9. Okay, so this is actually, I like actually the way that he phrased it, because then that clarifies a lot of things. Place one or more digits from 1 through 9 in every cell. So that means every cell has to have at least one digit, which clarifies that you can't have a blank cell, essentially. So, and then one of these cells obviously has to have more than one digit, because you can't fill 9 digit into 8 cells without having one extra. And that comes from set theory too. Huh. Interesting. Um, and the value of a cell is the sum of its digits. So for example, if this had both 4 and 9 in it, the value of that cell is 13. We also have black keys, which are, again, like as I said, I guess that's not accidentals. Accidentals are the markings you make to modify a certain note, essentially. I guess they're just essentially black keys, but they're essentially like they have to be like C sharp or D flat or D sharp or E flat or F sharp or G flat, etc., right? And they are these black things here, which are black keys. but they act as black crop key dots, where values separated by a black key are in a 1:2 ratio. That is, unless the black key is broken, in which case the ratio will be the same as the ratio written in next to the row. For example, values of 8 and 10 could appear on either side of a broken key in a row with the clue 5, 4. And I noticed this is actually like basically time signatures, right? You have 3, 8 time or 3, 4 time. And those are actually fairly common, not the most common, but they're fairly common time signatures there. So that's pretty cool, actually. I wonder what this one is, actually. Huh. Anyways, this broken key. So if this were, say, a 4 in value, you would know that you would have to have a 2 or an 8 in value in the cell next to it, because the black keys separate digits that have, or sorry, cells that have a value in a ratio of 2 to 1. But if it's broken, which means it has this little red mark, it must have a ratio basically the same as the one that's next to the row. So this would have to be in a ratio of 3 to 8. Therefore, you could have something like 3 and 8 in value here, or you could have something in value like 6 or 16. Or 16 to 6, right? We don't know which direction it goes. Therefore, this ratio here would have to be 3, excuse me, a 3 to 4 ratio here. And we don't know what the ratio is for these keys. This is obviously still a 1 to 2 ratio here. That's actually pretty fascinating. I'm not sure. I like it just because of like the time signature. Very well done. It's very cool. Anyways, that is how black keys work. They essentially work as crop key dots unless they're broken. And then they are in a ratio of the time signature that's outside that row. We also have even tape, where each tape strip has an even sum. So these must add up to an even sum, essentially. Well, that was weird. I don't know what. Huh. Interesting. Anyways, each tape strip must have an even sum, so these must sum up to like 22 or 8 or 16 or whatever, right? And then finally, we have a crescendo, which is also known as a greater than sign, but in music, this is crescendo, which is basically going from soft to loud, or small to larger. And values increase along the crescendo mark, starting from the pointy end, which is how it works in music too. So this must be smaller and this must be larger. Those are all the rules, actually. Very cool. And if you want to play along, there's going to be a link in the description. Now, I'm going to get started. Let's play this Etude for a Broken Piano. Okay. So these are all in 1 to 2 ratios. If there's only one Schrodinger cell per row, so you cannot have a set of 4 digits or 4 cells have a 1 to 2 ratio, and then another set have 3 cells in a 1 to 2 ratio. If you try to change something about 1, 2, 4, and 8, so you had to try to like have 2, 4, 8, and 16 or something like that, or 1, 2, 4, 8 with 2 added up. The problem is that you can't have 3 unique digits add up together, right? You can't have 3 unique digits be in a 1 to 2 ratio then, if that's the case. So this almost certainly has to be 1, 2, 4, and 8. This must then be 3, 6 with something adding up to 12. So this has to be 1, 2, 4, and 8. So it's 1, 8, 1, 8, 2, and 4. So none of these are Schrodinger cells. And one of these must be a Schrodinger cell, with this being 6. So this cannot be Schrodinger either. None of these can be Schrodinger, so and this one obviously can't be. We have to have 3 and then 12, because you have to have two 1-to-2 ratios. Well, we only have 5, 7, and 9 remaining of the digits, so it has to be 5 and 7. So this is 3, 5, and 7, and then this must be a 9 here. This is 1 or 8. We know 3, 5, and 7 but both have to be here. So that eliminates 3, 5, and 7 in the rest of the region. So we are left with 1, 2, 4, 8, and 9. Obviously, this can't be 1 or 8, because if this is 1 or 8, then this would have to add up to 9, which is not an even digit. So it's either 2 or 4 with 8, or 9 with 1. We're not sure which. This must be... This has to be a 3 to 8 scenario. If this is specifically 3 and 8, that does not work. Because, well, okay, hold up. No, it could work, potentially. Okay, this is specifically 3 and 8 in value, or 6 and 16 in value, right? Because you can't have more than 2 digits in a Schrodinger cell, particularly in the way that it's defined here. So you could have... This could be either 3 and 8 in value, or 6 and 16 in value. If it's 6 and 16... Obviously, the 16... So, say we had 6 and 16. 16 would have to be the Schrodinger. So, and it would have to be 7 or 9. So, let's just use that. 6, 7, and 9. 6 would then be in a 1-to-2 ratio with 3. 7 and 9 would be in a 1-to-2 ratio with 8. And this would be 1, 2, and 4. So, that is possible. This could also be 3 and 8. And the question is, does that eliminate anything, really? If we had 3 and 8 as single digits, this 3 would then have to be in a ratio with 6. And the problem is this would have to be 3 different digits, so it would be 1, 2, and 4. But then the 8 would have to be... I guess the 8 could be in a 1-to-2 ratio with 16. So that's 7 and 9. So that could work if this is 1, 2, 4. So if this is 6, it's with 3. This is 7, 9 with 8. Therefore, this would be a 1, 2, and 4. And this would be 5. That works. And we have 3 and 8 as single digits. 3 is in a 1-to-2 ratio with 6. It cannot be 1 and 5 or 2 and 4 as a Schrodinger, though. Because if we tried to have that as a Schrodinger, so say we had 3 and 8 with 1 and 2, 4, 1 and 5, say, and then this was 8 with 4, I guess. It would have to be because this is Schrodinger. Then we don't have 3 unique digits, which would be in a 1-to-2 ratio with each other. So it cannot be 3 with a Schrodinger. It has to be 3 with 6. And 8 could be with 7, 9 as a Schrodinger. That works with 1, 2, 4 there. Can it work with 4 here? If we had 4 here, we need the other 2 digits to be in a 1-to-2 ratio. It'd be 1 and 2, and then you would have a Schrodinger of 4, because you can't have a 4 here, but that Schrodinger would have to have 1 and 3, so that would not work. Could you have a Schrodinger adding up to non-16? No, because it has to be 1 and 3 adding up to 4. So this, if anytime you have 3 and 8 as a single digit, it must have 7 and 9 as a Schrodinger. So you would always have 6, 8, 3, and 7 and 9 as some possibility. What about if you had 3 as a Schrodinger? Then that would be, there would be no, 3 as a Schrodinger would be just 1 and 2 added up. Therefore, there would be no single digits, which would be in a 1 to 2 ratio with 2 other unique digits, which is not, so that would not work. What about 8 as a Schrodinger? If you had 8 as a Schrodinger, that would be either 1, 7, 2, 6, or 3, 5. Obviously, couldn't be 3 because 3 would be there. If you had 1, 7 as a Schrodinger, you would have to add up with 4 because 16 is not a single digit. So 1, 7, even so you miss out on a 4, and there's no 3 digits that would be in a 1, not, sorry, no 1 digit then that would be in a 1 to 2 ratio with the remaining digits, right? Because 4 would already take up the value. So this always then has to be 6, 3, 8, and 7, 9 in some order. And this must be 1, 2, 4. So this is 2, and one of these is 1 or 4, and this is 1 or 4. We could have 3 in the middle, or this is just 3, 6, 8, 9 in some order. With, sorry, 3, 6, 7, 8, 9 in some order. This is a 5. So this is non-Schrodinger. These are non-Schrodinger. But there has to be a Schrodinger in one of these. We're not sure which. This can't be 2 anymore because of the 2 in the column. These can't be 1, 2, or 4, so we have 3, 5, 6, 7, 8, 9. This can't be 6 because of that 6. This is the 3 to 8 ratio. The problem is 3 can be on either side of the ratio. 8 can be on either side of the ratio. It could be 16 on both sides. It could be 16 on one side, or 6 on the other side, or 3 and 8. We just don't know. These digits have to be no 2, 4, or 9. So it could be 1, 3, 5, 6, 8, 7, 8. This can't be 5 because of the 5 in the column. We don't know anything about this. Okay, we have 3 to 4 ratio. That's a lot more possibilities. 3 to 4 ratio. Could be 3 to 4. Could be 6 to 8. Could be 9 to 12. I think those are actually the only ones, right? Because like, you only have one Schrodinger again, right? 3, 4, 6, 8, and 9, 12. Right. 3, 4, 6, 8, or 9, 12. Let's try 9, 12 to start. Well, if it's 9, 12, so this would be 9. This would have to be the 12 because it's in a 1 to 2 ratio. 9 is not a 1 to 2 ratio with anything else. So this would be 4, 8, or 5, 7. The 2 and the 4 would have to be here. But this could not be 2, so this would have to be 4, 2, and 8 in some order. The problem with this 9 and 12, then this would have to be 5 and 7. That would force this to be 6 and then 3, and then this would be 1. Okay, so that's valid. 9 and 12 does work, but specifically in this order. What about 3 and 4? That's interesting. So if we had the digits 3 and 4, this has to be 3, 4. We don't have 3 and 6 anymore. We don't have 4, 8. For two of these digits, then it has to be 1 and 2 with another 4. So this cannot be 3 and 4 as single digits. What if it's Schrodinger? If we had 1, 2, and 4, the problem is that we don't have 3 unique digits, one which is in a 1 to 2 ratio with 2 other digits. So that doesn't work either. What about 4 being a Schrodinger? If 4 is a Schrodinger, it's 1, 3 with 3 as a single digit, which is not allowed. So this cannot be in a 3 to 4 ratio. What about 6 to 8? Well, if we have 6 and 8 just as the single digits, the problem is if we have 6 and 8, you can't have 2 here because of the 2 in the column. So that can't be 2, 1, 4. You could have potentially 2, 4, and 8, with the 8 being the Schrodinger. But the problem is that you need another 3 ratio here, right? So if this is 8, that would be 4 and 2. Yeah, I don't think you can come with 6 and 8, actually, as single digits. Right, because if you tried 8 as... So tried 8 and 6 here as single digits. This can go either up to 12, but then I would have to go down to 6, and therefore the 6 would be a Schrodinger, which doesn't work. Or it could go down to 3, and this is back to 6, which makes this a 2, 4, or a 1, 5 Schrodinger. Even if we tried 1, 5 or 2, 4, these can't be Schrodinger, and then you don't have... One of them requires a 1 or 2. So you can't have 1, 2, and 4 be the Schrodinger, and you couldn't even have it because of the 2 there anyways, right? So 6 doesn't work as a single digit there. What about if you had 6 here and 8 here as a single digit? You could go 16. You can't go up to 16, because if you go up to 16, that's a Schrodinger, but then you need an 8 here. Or 32, but that's not allowed. That isn't a single digit. And the 8 would have to be a Schrodinger because of the restriction of the row. So this has to be at least 4. It can't... You don't have a 1 to 2 ratio here that works with 2 unique digits for 1 digit. So this could be 2, but the problem is then you have to have 3 unique digits, which are in a 1 to... Sorry, 2 unique digits and a Schrodinger, which are in a 1 to 2 ratio with each other. And those there is no possibility with 6, 8, 4, and 2. 1 and 3 are not in a 1 to 4 ratio. There's no digits that are in a 1 to 4 ratio with anything else. And you don't have another 1 to 2 ratio, right? 1 would have to be with 2, 3 would have to be with 6, and none of those would work. So if we try to have a Schrodinger here, we still have the same problem because we have no 3 unique digits, which with 1 being in a 1 to 2 ratio with the other 2. So this cannot work as single digits as 6 and 8. What happens if one of them is Schrodinger? I don't think that works also. If one of them's Schrodinger, that means this has to be in a 1 to 2 ratio with 2 other unique digits. So that means this would have to be 2, 4, 8 here. So you'd have to have 6 and then 8 be a Schrodinger, but you already have 4 already taken. And then this can't be 8, 4, and whatever. So this actually has to be 9 and 12 then. So we know this is 9. This has to be a 12 and is the Schrodinger. This must be a 2, 4, 8. So this is 4 with 2 or 8 on the other side. And these can't be Schrodinger. This can't be Schrodinger. This 12, it must be next to a 6, which is next to a 3. So this is 5 and 7, adding up to 12. And therefore, this is a 1. So these are not Schrodinger, and these cannot be Schrodinger either. That means in the rest of column 5, you can't have a Schrodinger. This 9 eliminates a 9 here. So this is a 2 or 4 left in this tape. Therefore, it must be with an 8 to be even. This is also even, but we don't... Okay, so it cannot be with 6. That means to make an even digit, you need 2 odd digits here. So this has to be a Schrodinger, which means this cannot be Schrodinger. This cannot be Schrodinger because we don't have a 2 or 8 because of the 2 or 8 already in the box, 2-8 pair. And this can't be 6 because of the 6 in the column. So this has to be Schrodinger. This can't be Schrodinger. This can't be Schrodinger. This is 8, which makes this a 4, which makes this 2, which makes that a 1. So 1 cannot be here. 8 cannot be here. This is 2 or 4 here. 8 cannot be here. 9 cannot be here. This can't be 6. So this is 3, 6, or 7. Well, it cannot be 7 by itself. 7 always has to be with the 9 as a Schrodinger. And this can't be a Schrodinger, so this can't be 7 or 9. This can't be 7. This has to, both of these have to be 3 and 6, or 6. So this is 3 or 6, which eliminates 3 and 6 in the rest of the row. This is not a Schrodinger, so one of these two is. That means this can't be Schrodinger, because one of these two is. That means we have an 8, 7, 8, and 9 here. 8 is one of these three. This is 4. This is 2, 8. 6 has to be outside here. This has to be a 2, 4, 8, and 9 quadruplet. So this can't be 9. This must be 1, 3, 5, 6, and 7. And 6 can't be here. Okay. One of these three is Schrodinger. This cannot be 5 or 7 because the 5 or 7 eliminates 5 or 7 in the rest of the column. So this is 1, 2, 3, 6, 8, 9. And these are 1, 2, 3, 6, 8, 9. This can't be 4 because of the 4 in the column. This can't be 2 because of the 2 in the column. This is an even amount, no matter what. So it's either 8 or 16. Since this is even, this must be with the even. It cannot be with 2 or 6. So this has to be a 4 because the 8's already accounted for here. So this can't be 8. This can't be 9 because of the 7, 9 pair there. This is a 4, which means this can't be 4. This is 8 or 9. This must either be 8 or 7, 9. That eliminates 8 and 9 in the rest of the column. So this can't be 8 or 9. This has to have a 1 somewhere because there's no 1 in that column already. So this can't be 1 because there's no 1 else here. Where's the 1 in column 5? It has to be here. So this is 1. We have, what, 2, 3, and 6 left. This can't be 3 because of the 3 in the column. This has to be 1 with, this can't be 6, with 3, 5, or 7 left. Because we don't know if this is 8 or if this is 7, 9. 4 is one of these two. We don't know which. This is in a 1-to-2 ratio. Well, it could be with a Schrodinger. Interesting. But 9 doubled this can never be 9. Because if it were 9, it would be 9 doubled or 9 halved. 9 doubled is 18, and 2 unique digits can never add up to 18. 9 halved can never add up to, can never be a digit. It's 4.5. And it can't be the sum of a digit. Okay, so this is Schrodinger. We have Schrodinger, one of those three. This is Schrodinger. These are single digits. Interesting. Cannot have 2, 4, or 6. So it's 1, 3, 5, 7, 8, and 9 as possibilities. This ratio, what could this ratio be? Huh. This cannot be 4 because of the 4 in the column. This is 1 or 9. Hmm. Hmm. Obviously, it can't be 1 because there's only one Schrodinger allowed here. It could potentially be a 2-to-1 ratio. Still, yeah. Is it right? It still could be 2. Could be 3-to-1 potentially. Yeah, if it's 2-to-1, that still works with Schrodinger though, right? Well, maybe. How would that work? Hmm. This is smaller than this sum. But the problem is it could be a lot of things, right? So this could be a lot of sums. These are the digits 1 through 7. These are the digits 2, 4, 5, 6, 7, 8, 9. These are the digits 2, 3, 4, 6, 7, 8. Hmm. Right. We have to figure out what the ratio is here. This is a single digit. That's interesting. I don't think it can be a 2-to-1 ratio. If it's 2-to-1, you could still have 1, 2, 4, 8 just in the op. Oh, you can't have 4. But you could have 4 as a Schrodinger. Hmm. Yeah, I just don't think that's gonna work, right? 4, 2, 1, 2 doesn't work. 4, 8, 4, 2 does kind of work as a Schrodinger, but then you don't have the Schrodinger available to be in a 1-to-2 ratio. So yeah, this can't be 1-to-2 ratio because first of all, you can't have 4 in either of these cells. So that precludes this from being 1, 2, 4, 8 as single digits. So one of these must be a Schrodinger, and since one of these is Schrodinger, you can't have a 1-to-2 ratio with 2 other unique digits there. Plus, yeah, you're always going to have a problem with 2 unique digits. I guess you could have 3 with 6 and a Schrodinger, but that doesn't really work. Um, so it cannot be a 2-to-1 ratio. 5-to-4 is very specific. I don't think that works. I think it has to be something like 3-to-1 or something like along those lines. Because I don't know how you're going to be able to get that many combinations, right? There's a 4 ratios which are like that, and only one of them can contain a Schrodinger, right? So these are ones that naturally digits have to have, except for one with a Schrodinger. And the only ones I can think of are 3-to-1, essentially. It has to be something along the lines of 3-to-1 in a ratio. Because if you have fractional ratios, you just don't have enough digits that are in that relationship, right? Say you have 2-to-3, maybe 3 halves, possibly. That would then be 3, 2, 6, 4, and 9, 6 as digits, right? But the problem is that requires 5 of the digits. So therefore, that doesn't work for 1, 2. Say we just excluded 1 with had a Schrodinger randomly. 1, 2. Oh, it has to be 3 and 2. I guess it could be 3 and 2. So 3 and 2 is a possibility. 3 to 1 is a possibility, I think. Right, because you have 3 to 2. Actually, it would be, no, 6 to 4, and then 9 to 6 as possibilities. So that's possible, actually. 4 to 3 doesn't work because there's not enough digits. So I think the possibilities are, we tried 2. That doesn't work because this can't be 2 or 4 here. So this must be a Schrodinger set here, which means this must be 1, 2, 4, 8, but 4 can't be in the middle sets, which means that those don't work. Right. So because of that, what else can you have? 3 to 1, 3 to 2. So we tried the smallest ratio. You have to try the smallest ratios, and then once you get a large ratio, it'll be too much, right? Because you don't have enough digits to fill it. So we tried 3. 3, 2 seems to actually kind of work. 4, 3, 1 might also kind of work. We don't know. What about, we tried 2 to 1. 5 to 2? That doesn't work because we have 5 and 2, and then there's no other pair of digits that are in a 5 to 2 ratio. What about 4 and 3? I don't think that works either, right? You can only have 4 and 3 and 6, 8 and 6. And then we don't have another 2 digits which are in a 4 to 3 ratio. So I think it has to be 3 and 2 or 3 and 1 as the ratio. We tried 2 to 1, that doesn't work. So 3 and 1 or 3 and 2. What happens if it's 3 and 2, this has to be a 6, and that's not possible. So I think it has to be 3, 1 then, right? Because the only way you have even 5 digits which are connected would be 4, 6, and 9, and then you have 3 and 2, right? Separate. And then you have the other 2 being a Schrodinger and another digit. And you have to have at least 5 which are specifically digits, because only one Schrodinger is per row. So this does not work for 3 and 2 because of the 6 in the column here. So that doesn't work. So this has to be a 3 to 1 ratio, which means if it's single digits, it's 1, 3, and 9. That does work here as a 3. And then you have 6 and 2 as the other single digits. 3, it has to be 1, 3, 9 because you have 1, 3, 2, 6, and 3, 9 are the 5 digits possible to be in a 1 to 3 ratio. Therefore, this must be 3 with 1 and 9. So this is 1 and 9, this is 1 and 9. That eliminates 1, 3, and 9 here. Because of the 1, 9 pair. This can't be 1, this can't be 3. This can't be 3, this can't be 3. We also know 1 has to be in one of the columns in columns 1 or 3 in row 3, and 1 has to be in one of the columns in column 1 or 3 in row 7, which eliminates 1 in the rest of columns 1 and 3. So this can't be 1, this can't be 1, this can't be 1, this can't be 1. Well, where does that leave 1 in this upper left region, this region 1? It has to be here. So this is 1, which eliminates 1 here. This has to be a 5, 7 Schrodinger then, because those are the only digits remaining. You can't have 3, you can't have 1, you can't have 9 or 8. So this can't be 5, 7. This can't be 5, 7, so this is 8 because it can't contain a 9. This 8 eliminates 8 here, so this is a 9, which eliminates 9 in the rest of that row. This can't be 3. This can't be 3. The 2 and the 6 have to be together, and this does not contain either. So this has to be the 2, 6 pair, single digits, and these are all non-Schrodinger. So this has to be a 2, 6 pair, which eliminates 2 and 6 in the rest of the row. This can't be 1 or 9 or 3. This is 5 or 7 in a 1 to 2 ratio. Sorry, 1 to 3 ratio. It would have to be with 4. It has to be 4 and 12, right? We don't have 1, 2, 3, 6. 5 would be with 15. Oh, 5 could be with 15. Okay, so it's either 5 with 15 or 4 with 12. 7 would have to be 21, and that's not the sum of 2 digits. So we don't know what this is. This is either 5 with 7, 8 as a Schrodinger. So one of these has to be Schrodinger, so this can't be Schrodinger here. So if this is 5 and 7, 8, that could be with 4. One of these is 4, essentially, so this can't be 4 here. Or it's 7, 5 and 7 with 4 here, and this is 8. So 7 can never be here, essentially, is the point. Okay. 7 has to be one of these two. 5 has to be one of these two. It's either 5, 7 with 4 or 5 with 7, 8. So this is always 4, 5, 7, 8, which eliminates 4, 5, 7, 8 in the rest of the region. This can't be 5, 7. Can't be 5, 7, 8. This can't be 7 or 8. Okay. This can't be 8 either. So one of these two is a Schrodinger. Therefore, these can't be Schrodingers. Where is the Schrodinger in column 8? It has to be here. So this is a Schrodinger, which means this cannot be Schrodinger. This must be larger than this. We have to have a Schrodinger here somewhere. This must be an odd sum. Cannot have 1. There's no 1, 3. So this is 2, 4, 5, 6, 7. This is 2, 4, 5, 6, 7 also. We have a 2, 6 pair. Where is the 1 in column 4? It has to be here. So this is 1. One of these two is a Schrodinger. We don't know which. If this is Schrodinger, that means this is Schrodinger 5, 7, that's 4. Okay, right. So what are the possibilities? This is 5. That's not a Schrodinger. So this would have to be Schrodinger 7, 9. This would be 8. And this would be 8. Ah, that doesn't work. If this is 5 and this is non-Schrodinger, this must be the Schrodinger. This is 7, 8. This can't be Schrodinger, but this must be 8, which eliminates 7, 8 as a possibility. So this can never be the 5 with the 7, 8. This has to be Schrodinger, which means this can't be Schrodinger. So this is the 8 by itself. This is 8 with the Schrodinger being here. This is not Schrodinger. So this cannot be 7 or 9. This has to be 4. This 8 eliminates 8 here, so that's 9. This 5, 7 eliminates 5 and 7 here, so that's 3, which makes this a 1. The 7, 9 pair eliminates 7 and 9 in the rest of the column. So this can't be 7, this can't be 9, this can't be 9. We have a 2, 6, 2, 6 pair in the region 8, so that eliminates 2 and 6 in the rest of the region. Therefore, this can't be 2 or 6, it's 3. This can't be 2, 6, or 3. That's 3 in the corner. We celebrate because we know we're getting close to solving it. This 9 means this can't be 9. Sorry, this can't be 2, 3, or 6. This is 9. This 2, 6 pair eliminates 2 and 6 in the rest of the column. So this can't be 2. This can't be 6. This 3 eliminates 3 here. This can't be 3 because of a 3 in the row. 7 has to be one of these two. And it's either with 6 or 8. This 3 eliminates 3 here. So this is a 2, 6 pair, which eliminates 2 and 6. Oh yeah, this has to be 3 and 8 to be in a 3 to 8 ratio. This is 6, which eliminates 6 here and here. So this can't be 6. This is 2. This is 6, which means this can't be 6. This is 2, which makes that 6, which makes that 2. This can't be 2. This is a 4. This 4 eliminates 4 here. So this is 8, which makes that 4, which makes that 8. This can't be 8 or 9, so this is 2. This can't be 6 here, so this must be 8, which makes this 5. This can't be 8. This is a 6, 7 Schrodinger. This is 7, 9 Schrodinger. 5, 7, 5, 7. 2 cannot be any of these. 2 cannot be here, so this must be 4. These can't be 4 then. We have 9 having to be in columns 1 and 3 in row 2, and 9 having to be, well, okay, we already have all the 9s, so that's fine. This can't be 4 or 6. So 3 has to be here. So 3 cannot be in the rest of that region. If this were Schrodinger, that would not work because this sum would be greater than 5 or 7 could ever be. 4 and 5 is 9 at least. So this cannot be a Schrodinger. This is a Schrodinger of 5, 7, so that eliminates 5 and 7 in the rest of the region or row. So this is a 3, 6 pair. Okay. This is odd. This sum, if it's a sum, has to be odd. If there is a... Okay, so this cannot be Schrodinger because the sum of that is greater than that would be as a single digit. So only one of these can be 4 or 6, which means the other 4 or 6 has to be here. And if it's 4 and 6 and an odd digit, that would make this an odd tape, which does not work. So it has to be Schrodinger here. Since this is Schrodinger, this cannot be Schrodinger. This has to be a Schrodinger. This Schrodinger eliminates Schrodinger's there. This can't be Schrodinger. Therefore, this is the Schrodinger here, which means it's the sum of 5 and 7. This is a 3 here. That 5 and 7 sum, that's 3 in the corner. We celebrate because we know we're close to solving this. This must be a 6. This must be 3. This 5, 7 pair eliminates 5 and 7 in the rest of the column. This can't be 5 or 7. This is 8, which makes this 2, which makes that an 8. This 2 eliminates 2 here, so it's 9 and 2. This 9 eliminates 9 here. So this is 1, which makes that 9. This 1 eliminates 1 here, so that's 4, which makes that 1. 5 and 7 cannot be here. This can't be 4. This must be 6. 6 can only be less than 7 as a non-Schrodinger, so this has to be 6 and 7. That eliminates 7 here. This can't be 5 or 8, so that has to be a 7 there. And that's how you solve it. Yeah, I don't know if I consider this hard. It's just, you just have to go through the logic of it. Yeah, very cool logic, actually, throughout. I guess there were some little difficulty parts, but you just go through them, right? This being a 3 to 8 ratio, you had to have it be 3 and 8 with 6 and a Schrodinger of 7, 9. So that always had to be the case. While it could be 3, 4, 6, 8, or 9, 12, if you go through the scenarios, you'll basically understand that it can only be 9 and 12 there. which informed this where this could be, and that informed this. So this could not be a 1-to-2 ratio. We tried 3-to-2, but that doesn't work because of the 6 in the column. So yeah, very cool logic throughout, actually. And very cool use of a piano and the black keys being the Kropke ratios, except when they're broken, unfortunately. Um, it'd be sad to see a piano in the state of in this state because there's a lot of broken keys, and really, I'm not sure why you have tape on each individual key. That's kind of weird, but anyways, like I don't know what the tape would be taping, right? The tapes. I don't know. I don't know what it wouldn't be in between keys either, because then that would defeat the purposes of having individual keys. But I don't know why you would have tape on a key. Anyways, that was the Etude for a broken piano. Kind of sad. What would 3-1 is not a typical time signature, so that makes sense why this is just a question mark. I'm trying to think if you ever have like a 9-3 time or something like that, or 6-2. No, you do have 2-to-1 ratios, right? So you do have 8-4 time sometimes. You do have some stuff like 7-4, 6-4, 3-2 time. Yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.